Now let's talk about cubic. Cubic is polynomial with 3 roots. And let's take it as the root as alpha, beta, and gamma. Now, because of this, the highest power will be 3. Now let's see how it will be like. It's going to be something like this: ax cubed plus bx squared plus cx plus d is equal to 0. Now, we can also express this again as x cubed plus b over a x squared plus c over a x plus d over a is equal to 0. Now, let us see how, this is formed by multiplying x minus alpha by x minus beta by x minus gamma. We know the product of this as x squared plus minus alpha plus beta plus alpha beta. Now let's multiply it with this. It's going to be, okay, let me do it like this. For ease, so this is going to be x cubed minus alpha plus beta x squared plus alpha beta x. This one is going to be gamma x squared. Okay. Now gamma minus gamma x squared plus alpha plus beta into gamma x minus alpha beta gamma. So the product is going to be x cubed, with this minus alpha plus beta plus gamma into x squared. I added this one to this one. So this one is added to this. So I'm going to have plus, you can see, alpha beta plus alpha gamma plus beta gamma x minus alpha beta gamma. So let me write it out clearly. It's going to be x cubed minus alpha plus beta plus gamma x squared plus alpha beta plus alpha gamma plus beta gamma x minus alpha beta gamma. So this will be equal to this. Now let's do some equivalence. This one is equal to 0. This one also is equal to 0. So at the end of the day, you can equate the two and say it's equal to x cubed plus b over a x squared plus c over a x plus d over a. Now, by the time because we have equated the two, we will now equate the coefficients to really know what this is in this equation. Let's see what I mean. We have multiplied this, we have gotten this. And this one is the equation formed from the multiplication of this. Now, let us equate the coefficients. You can see that b over a here, so let's say minus b over a will be equal to alpha plus beta plus gamma. And from our notation, this one is going to be S1 or summation alpha. For this one now, we can see that c over a, please take note of the minus sign here. C over a is equal to alpha beta plus alpha gamma plus beta gamma. So in this place, we don't have S for it. It's going to be summation alpha beta. You can see the necessity of having that notation that was introduced. Now, look at this. We have minus d over a will be equal to alpha beta gamma. So this is summation alpha beta gamma. So as the power increases, you'll be seeing more of this. As the power increases, when you get to 4, you will see what it will be like. So you can see, these are the things you want to bring out from the expansion. Notice the sum is minus b over a. The sum of pairs is c over a. The sum or the product of all the roots is minus d over a. That is minus 1 multiplied by the constants over a. Now, let's see some workings. At least we have known some of the practices. Let's see some of the workings you can handle from this. Now, let's look at the sum of the reciprocal. That is 1 over alpha plus 1 over beta plus 1 over gamma. Now, what is going to be? Alpha, beta, gamma. And then we are going to have this one to be beta gamma plus alpha gamma plus alpha beta. And if you look at this, this is equal to C over A. And this one is D over A. Sorry, this is minus C over A. D over A. So at the end of the day, you are going to have this to be equal to minus C over D. Just like in, what's it called? Quadratics. So you can see the formulas are similar, very similar. But it's good you know it for each of the polynomials. This one, even this, they are very similar. By the time you also look at the sum of the squares, that is alpha squared plus beta squared plus gamma squared, you will see that there is great similarity. Let's see how we are going to do this. You know, we can get it. Let's expand alpha plus beta plus gamma. Let's square it. Now, from the summation technique, we have been able to get the sum of the roots, the sum of the pairs, the product of pairs, and the product of all the roots, minus d over a. The sum of the reciprocal, you can see, it is minus the coefficients of the x divided by the constants. Just like, what's it called? Just like in quadratics. Just like in quadratics. So it's the same thing, you can see. But the only thing is that in quadratics, C is the constant, B is the coefficient of x. So that is just the thing. Coefficient of x divided by the constant. You can see all of this. I'm trying to show you the similarity. Now for here, we have this alpha, beta, gamma. Alpha, beta, gamma. Explain. Alpha squared, alpha beta, alpha gamma. This one is alpha beta, beta squared, beta gamma. We also have this to be alpha gamma, beta gamma, gamma squared. So if I should write out the answer to this, I can say that alpha plus beta plus gamma all squared. You know what we are trying to achieve? Alpha squared plus beta squared plus gamma squared. That is summation alpha squared. Remember the notation, please. Take notes. So we are going to have it like this. What is it giving us? You can see I have alpha squared plus beta squared plus gamma squared. This is this. Now, alpha beta, that is 2 alpha beta. Alpha gamma, alpha gamma. And this one, I have beta gamma, beta gamma. You can see, so I can easily find this because I know this. Therefore, alpha squared plus beta squared plus gamma squared is equal to alpha plus beta plus gamma all squared minus 2 into alpha beta plus alpha gamma plus beta gamma. And we know what alpha plus beta plus gamma is. That is summation alpha squared minus 2 summation alpha beta. You can see the similarity now. Even in quadratics, it's still the same. That's what I want to show you. This, if you have already known it in quadratics, it will be very easy for you when you get to cubic for quartics. So just learn this. It's very easy and straightforward. Now let's look at some examples. You know this is this C over A. This is square. Sorry, let me put bracket here because this one. So you can see the difference between this and this. Please take notes. So this one, summation alpha, is this one. So you are squaring it. Minus 2 summation alpha beta. You can see. You can see. So thank you. Now let's go into some examples and put this to practice. Now let's look at this. Given that s cubed plus 2x squared plus 5 equals 0, find using summation form the values of s1, s2, s3, and s minus 1. You know we have gotten some of the formulas. Now let's apply. You know that x cubed plus 2x squared plus 5 equals 0. Now let's write it out, because normally this is supposed to be up to 4 places. We are having 3. So which means that 1 is 0. The coefficient of 1 of the x is 0. And that is of x, or the powers of x rather. So we have x squared, x cubed, plus 2x squared, plus 0x, plus 5 equals 0. So you can see, we have it in 4 places. For s1, we know it is equal to minus b over a, and that is minus 2 over 1. For s2, we discovered that it is summation alpha squared minus 2 summation alpha beta. So, what is summation alpha? And that is minus 2 all squared minus 2. What is summation alpha beta? That is c over a, 0 over 1. This is 4. Now, for s cubed, I work that out to be clear. But we know what s minus 1 is equal to minus the coefficient of x over the constant, minus 0 over 5, and that is 0. For s3, let me work it out before I show you the derivation. It's going to be summation minus 3 summation alpha beta plus 3 summation alpha beta gamma. We know what this is. We know what this is. We know what this is. And we know what this is. We know what this is. This one is minus 2. So we cube it. Minus 3. What is summation alpha? That's minus 2. So 3 into minus 2, sorry. Alpha, summation alpha beta, that is 0. Plus 3. What is summation alpha beta gamma? That is minus 5 over 1. So that is minus 5. That is minus d over a. So this is going to give us minus 8 minus 15, which is minus 23. So we have derived this one initially, derived this one. Let me derive S3 for you using summation. Now, just to find the formula for the summation for S3, I work it out for you. We know that this one, when we express it in terms of S, is going to be A S3 plus B S2 plus C S1 plus 3D equals 0. Just want to work it out short form so that it will be easy for you. You can do it, expand and expand, but this one is very short and easy for me. So I can now say S3 plus D over A S2 plus C over A S1 plus 3D over A equals 0. Now, we know that B over A is equal to minus summation alpha. Remember, C over A is equal to summation alpha beta. And D over A is equal to minus, D over A is equal to alpha beta gamma. I think that there should be minus here. Yeah. There is minus here. So let us substitute this back into this equation. So you have S3 minus summation alpha into summation alpha squared plus summation alpha beta into summation alpha plus, okay, this is minus as well, minus 3 into alpha beta gamma. Now, we have this common to these two. So we have S3 minus summation alpha into summation alpha squared minus summation alpha beta minus 3 alpha beta gamma. You know this, you know the formula for this is going to be, you know that alpha, summation alpha squared is equal to summation alpha all squared minus 2 summation alpha beta. So let us substitute this with this. So we have S3 minus summation alpha into summation alpha squared minus 2 summation alpha beta minus summation alpha beta minus 3 alpha beta gamma equals 0. And we are going to have this to be S3 minus, when we multiply this out and work this out, we are going to have summation alpha all cubed minus 3 summation alpha beta summation alpha. Okay, this one will cover this. Minus 3 alpha beta gamma equals 0. So S3 will be equal to summation alpha all cubed minus 3 summation alpha beta plus 3 alpha beta gamma. So you can see when I brought this, all of this is in brackets. I placed it here, and this one is having minus in the front. So this is the formula for S3. You can also multiply out, but I believe this is the very short way to get the answer. So we have already solved this. You can see how easy it is. Just be cautious and take the necessary sign when you are working it out. Now let's look at another example. For the cubic equation, 3x cubed plus 2x squared minus 4x plus 1 equals 0. Find the value of S3. We can use recurrence and we can use summation. So if we are using summation, you know that summation alpha cubed is equal to minus 3 to summation alpha beta plus 3 summation alpha beta gamma. So let's see what this will give us. What is summation alpha? That is minus 2 over 3. Summation alpha beta, that is minus 4 over 3. What is summation alpha beta gamma? That is 1 over minus 1 over 3. The minus should be there. Please take it. Now, so please take notes. So, what is summation alpha? That is minus 2 over 3 cubed. 3. Again, minus 2 over 3. Summation alpha beta minus 4 over 3 plus 3 into minus 1 over 3. So this is going to be minus 8 over 27. This one cancels this. Minus 8 over 3. This one is minus 1. Let's do something. The LCM is 27. Minus 8. 8 times 9, 72. Minus 27. So this is minus 107 divided by 27. So we have minus 107 divided by 27. Now let us use recurrence to solve it. Now let's use recurrence. So I'm going to have 3x squared x cubed plus 2x squared minus 4x plus 1 equals 0. So we are going to have this as 3s3 plus 2s2 minus 4s1 plus 3 equals 0. Now we find s1 and s2. And it's easier to find these two using some summation. So s1, we know what that is. Minus 2 over 3. S2, we know that will be summation alpha squared minus 2 summation alpha beta. And that is minus 2 over 3 squared minus 2. What is alpha summation alpha beta? That is minus 4 over 3. Okay, yeah. So this is going to give me 4 over 3, 4 over 9, plus 8 over 3. So this is 24 plus 4. That's 28 over 9. Now, I will now substitute these two into this equation. So I have 3s2 plus 2 into 28 over 9 minus 4 into minus 2 over 3 plus 3 equals 0. So this 3s2 plus 56 over 9 plus 8 over 3 plus 3 equals 0. So let me continue with this. So I have 3s2, no 3s3, sorry, 3s3 plus 56 plus 24 plus 27 over 9 equals 0. So 56 plus 24, that is 80. 80 plus 27, 107. So 3s3 will be equal to minus 107 over 9. 107 over 9. Therefore, S3 is equal to minus 107 over 27. So depending on, unless you are given the specific technique to use. If not, just you can use either of the above. Either of the two I have used here to get S3. And from there you can even form your equation with cube of the roots. S minus 1. For the cubic equation, s cubed minus 3x squared plus 4 equals 0. Find the value of s minus 3. We have this equation originally. Minus 3x squared plus 4 equals 0. And we have to find s minus 3. Now, I would like us to make it like this. X cubed minus 3x squared plus 0x plus 4 equals 0. Since we are looking for s minus 3, recurrence is the best technique to solve this. Now let's divide through by x cubed. So we are going to have 1 minus 3x squared over x cubed plus 0x over x cubed plus 4 over x cubed equals 0. At the end of the day, we are going to have this. So we have 1 minus 3 over x plus 0 over x squared plus 4 over x cubed. Now, if we should express this in terms of s, we are going to have it like this. 1 times 3, because it is 3, this is the constant now, minus 3s1 plus 0s2 plus 4s minus 3 equals 0. So, looking at this, s2, we don't need to start looking for, sorry, this is s minus 1. We don't need to start looking for s minus 2. We have our s minus 1 already. We know what to get, how to get it. So, at the end of the day, our equation is going to be 3 minus 3s minus 1 plus 4s minus 3 equals 0. And we have already discovered that to find s minus 1 is going to be the coefficient of x over the constants minus coefficient of x over the constants. And what is the coefficient of x? That is 0. So s minus 1 is equal to minus 0 over 4, and that is 0. Therefore, 3 minus 0 plus 4s minus 3 is equal to 0. So 4s minus 3 is equal to minus 3. S minus 3 is equal to minus 3 over 4. So you can see how easy it came out. Once we know how to, we know how to get this from summation. This one, we might have needed to get s minus 2 before, but because the coefficient is 0, that's obligation we absorbed of it. Therefore, that's it. Very simple and straightforward. Now we have it. Given that x cubed plus x squared minus 5 equals 0, as roots alpha, beta, gamma. Find the cubic equation with roots 1 over alpha minus beta, 1 over alpha minus 2, 1 over beta minus 2, and 1 over gamma minus 2. Yes, you can try to use summation and find each root. You can find summation alpha. You know, since this is, let's say this is alpha. So we have this. Given that x cubed plus x squared minus 5 equals 0, as roots alpha, beta, gamma. Find the cubic equation with roots 1 over alpha minus 2, 1 over beta minus 2, 1 over gamma minus 2. This one, the best way to go about it is substitution. You have done substitution for quadratics before to explain it. So substitution is the best way to go about it. Now let's look at how we go about it. We'll just do something like this. Y equals 1 over x minus 2. So what is x now? We make x the x subject of this formula. So x. So we now make it like this. Xy minus 2y is equal to 1. So 1 plus 2y over y, 1 is equal to x. 1 plus 2y over y is equal to x. We now substitute this for x in the original equation. So the equation is now going to be 1 plus 2y over y cubed plus 1 plus 2y over y squared minus 5 is equal to 0. This is very good in forming another equation, either cubic, quadratic, or quadratic. So using substitution makes the work faster and easier, depending on how you can do it. Now, let's see. So we are going to have 1 plus 2y over y all squared into 1 plus 2y over y plus 1 minus 5 equals 0. So this is going to give me 1 plus 2y over y all squared into 1 plus 2y plus y over y minus 5 equals 0. So this is now going to give me 1 plus 2y all squared into 1 plus 3y over y cubed minus 5 equals 0. So I have 1 plus 2y squared into 1 plus 3y minus 5y cubed equals 0. So let me expand this and this. So that's what it will be. So this is going to give me 1 plus 4y plus 4y squared plus 3y plus 12y squared plus 12y cubed minus 5y cubed. Now let's take it in turns. So this is going to give me 7y cubed plus 16y squared plus 7y plus 1 equals 0. So that is the new equation. Cubic equation formed with the root 1 over alpha minus 2, 1 over beta minus 2, and 1 over gamma minus 2. The equation x cubed plus x minus 1 equals 0 as roots alpha, beta, and gamma shows that the equation with roots alpha cubed, beta cubed, gamma cubed is y cubed minus 3y squared plus 4y minus 1 equals 0. Hence, find the value of gamma alpha raised to power 6, beta raised to power 6, and plus beta raised to power 6 plus gamma raised to power 6. That is the sum of the roots raised to power 6, S6. Now we have this x cubed plus x minus 1 equals 0. Now, if we use substitution, it means that y will be equal to x cubed. So, we can now say that x equals to y raised to power 1 over 3. We will now substitute y raised to power 1 over 3 for x in this equation. So we are going to have y raised to power 1 over 3 plus y raised to power 1 over 3 minus 1 equals 0. From here, I'm going to have like this: y minus 1 is equal to minus y raised to power 1 over 3. Now let me cube both sides. So I'm going to have y cubed minus 3y squared plus 3y minus 1 is equal to minus y. You know, when you cube this, it's going to give you minus y. From here, I can now say y cubed minus 3y squared plus 4y minus 1 equals 0. We can also change it back to, okay, so that is the equation with the roots, with the cube of the initial roots. From this place, we are asked to find the value of alpha raised to the power 6 plus beta raised to the power 6 plus gamma raised to the power 6. It will be very good for us to make the job easy by using summation. I think, yeah, using summation will make the job very easy. So, S2 is equal to summation alpha all squared minus 2 summation alpha beta. So what is summation alpha? That is minus 3 over 1 summation alpha, which is equal to 3. Summation alpha beta is equal to 4 over 1, which is 4. So if we now substitute this into this equation, so, you know, mind you, please, S6 in this situation is equal to, sorry, S2 for this is equal to S6 for this equation. So S6 here is equal to S2 here, because the root here is the cube. So I want you to get that into your consciousness. Therefore, S6, let me make it like this, S2 for this. S6, which is equal to S2 for the new equation, will be equal to 3 squared minus 2 into 4. And that is 9 minus 8, which is equal to 1. So you can see, very good and nice.